So here's the first strategy. We've already learned the strategy of graphing, where you can graph both of them and then find out the point where they intersect. Okay? Now we're going to learn some algebraic strategies. We also learned guessing and checking, where you just guess until you get it right. Now we're going to learn some algebraic strategies, and these will be the strategies used most going forward, like following years that use this over and over again. Okay? Now, here is one that you could easily solve with graphing, because they're both in y equals mx plus b form. You could graph them both right away, and looking at them, you might even be able to tell where they intersect. At 6, because they have the same y-intercept. So these ones, we already know from the graph that they're going to intersect at 0, 6, because they both have the same y-intercept. One of them has a slope of 3, so positive slope. The other one has a slope of -2. That'll be the only point where those two lines intersect. The substitution strategy algebraically says what you need to do is get a variable all by itself on one side of the equation. Both of these have a y already all by themselves. Okay? And if we say in the second example, this y says y is equal to -2x plus 6. So whenever I have a y, I could also write -2x plus 6 because they're equal. So if I know that, I can go back to my first equation, and instead of y, I can write -2x plus 6 is equal to 3x plus 6. See what I did? Instead of this y here, because I knew y was equal to -2x plus 6, I wrote -2x plus 6 instead of writing a y. What that does is it changes the question to have only one variable. And if it only has one variable, you go back to your grade 9 solving for x strategies. How would you get x by itself? Combine your like terms. Right? I could add 2x to both sides. That would give me 6 equals 5x plus 6. The 6's are like terms. I could subtract 6 on both sides, right? To get the 5x all by itself. 0 equals 5x. If I wanted to find out x, divide both sides by 5. And I get x equals 0, which we already knew. So it's no surprise. But it tells us that x is equal to 0. And once you find out that x is equal to 0, you could plug that in to either one of the two equations. Let's say I plug it here into equation 1. If I plug in 0 for x, what do I get? Y is equal to 0 plus 6, which is just y is equal to 6. And that's how we can find it algebraically. Okay? When we have two equations, like in this second example, in this example, when you have two equations, the first thing you're going to decide is which letter is the easiest to get by itself. The y. And in which equation is it easier to get y by itself? In the first equation or in the second equation? Second equation. All we would have to do is subtract 4x on both sides, and this equation would become y equals -4x plus 5. I'm going to call this equation 1 and those ones equation 2. Yes?
I remember I figured out with this, like last night when I was doing the homework, that pretty much just reverse the signs, and yeah.
And then you can move things from one side of the equation to the other?
Yeah, although with some of the harder ones, I did have to do quite a bit of guess and checking work on my calculator, because I would have like some signs certain ways, but then it wouldn't be in the right spot on the graph as it would be in the textbook, and sometimes that would take me forever.
Okay.
So for the homework last night, we were supposed to do guess and checking and graphing.
Yesterday's homework would have been all graphing stuff. Try to change it to y equals mx plus b and graph them and then find out where they intersect. If you can graph it by hand and the dots matched up perfectly, then it would be say it. If graphing by hand they didn't match up perfectly, then you'd go to your calculator to find it out. But now we're going to do some algebraic ones. Now, What we saw in this last example here is once you've got an equation with one variable, you can solve it, right? As soon as you have an equation with two variables, you can't solve it unless you have two equations. Sometimes solving systems of equations, you'll hear people say you can solve two equations with two unknowns. Two unknowns are x and y. So you need two equations if you have two things you don't know. If you have three things you don't know, you're going to need three equations. And there's even questions with four things you don't know. You'll need four equations and stuff like that, and you learn strategies for all of those. Right now we're doing two equations with two unknowns. So what we know is we've changed the second equation to y equals negative 4x plus 5, and now we can substitute in. You see that the first equation was 2x minus 4y equals 7. But instead of y, I'm going to write and we have to do it into the other equation. Because if you substitute it back into the same equation that you started with, you're not using two equations. You're only using one equation. And if you do that, you're going to find out something that you already know. You'll solve it, and you'll get 0 is equal to 0. Or 5 is equal to 5. But it won't help you solve anything. You have to plug it into the other equation. So all I did is in equation 1, where there was the y, I substituted in the negative 4x plus 5. That's the only thing that's new in this. After this point, it changes to a grade 9 question. How do you solve this? What would you do first? Combine like before combining like terms? Getting rid of the brackets. The distribution of the negative 4. So you get 2x. This negative 4 multiplies to that and to that. So plus 16x minus 20 equals 7. And these are like terms, so we'll get 18x. I can bring the 20 over to the other side by adding 20 to both sides. Equals 27. And then divide everything by 18. And that reduces. So now we found our x coordinate. We still have to solve for y. But once you find x, you just have to substitute that x value, which is 3 over 2, and you can do it into either equation 1 or equation 2. Which one do you want to pick?
2.
Equation 2? Do you want to pick the original equation 2 or the simplified, the y equals 1? It doesn't matter. The y equals 1? Okay. So we got y equals negative 4. Instead of x, I can write 3 over 2, and then it was plus 5. How do I multiply negative 4 times 3 over 2?
4 over 1.
You make it a fraction, 4 over 1. How do I multiply fractions? Cross divide? No. Cross multiply? Times the numerator by the numerator and the denominator by the denominator? Get a common denominator? What is the rule?
Oh, is it common?
Man!
Okay, make it into 2, the other one 2, and then it's
You got it right. You got it right.
2.
Yeah. I was just saying all these different, you have to multiply the tops and multiply the bottoms. That's the rule for multiplying fractions. You'll get negative 12 over 2, which is just negative 12 divided by 2, negative 6 plus 5. So what we do when we write our solution, because these were two lines that cross, we have to write the point where they cross. We know that the x-coordinate is 3 over 2, and our y-coordinate is negative 1. Circle around our solution.